Okay, so today we're going to look at section 3.2, which is all about simplifying our radicals. You know, radical is just kind of a fancy name for saying square roots. Okay, so we're going to look at how to break down and simplify when we have stuff underneath the radical. You're going to hear me probably say house a lot. You know, it's just kind of like a layman term referring to that. This shouldn't be new to you. I know we cover this a lot through Algebra 1, and I think we also kind of hit back on through this a little bit through Algebra 2 as well. So we're going to take 2 days to kind of talk about how to simplify these square roots. Today we're just going to look at examples and how to do this without involving some variables. So first, just kind of a quick rundown, looking at example A here. You know, what does it mean to be a square root? Well, we've been looking at some Pythagorean theorem stuff, so in order to solve, we need to take the square root, and what a square root does is it kind of undoes a square, right? You know, we came across stuff like, you know, what happens if our Pythagorean theorem came down to something like this? You know, we have a square, well, to get rid of the square, to undo a square, we have to square root it, okay? And that's what kind of letter A kind of hints at, you know, what perfect square, you know, what two things multiplied by itself can we get to 49? And we know we should have a pretty good idea of what our perfect squares are, 49 being that way. We can say that that is 7 squared, right? 7 times itself gives us a 49. So what that really does is it kind of takes away that square, right? We undid, you know, the x squared here. So this would be a 7 there. So it's kind of just a basic example of what a square root does. It just kind of takes away the squaring value of it. Okay, so a couple properties that we're going to hint at and kind of talk about as we get going here. The first is the product rule. And basically all it says is the square root of a product is the same thing as the product of their square roots. Okay, I know that kind of sounds like a mouthful, but you know, as you can kind of see a generic example, square root of AB is the same thing as saying the square root of A times the square root of B here. So what that means is, you know, if I have the square root of 8, okay, well, 8's not a perfect square. I can't break that down perfectly here. So, but what I can do is I can separate 8 as a product, right? Every number is a product of prime numbers. So what I can do is I can say, well, 8 is the same thing as saying 4 times 2. This is where that A times B comes into play here. And what that allows me to do is, instead of being under the same house here, the 4 times 2, I can separate them into their own separate houses. Okay, so the square root of a product like we have here is the same thing as a product of their square roots, okay? So, you know, just because everything's under one house doesn't mean it has to be that way. If we're dealing with multiplication, right, we're dealing with a product, we can separate those guys out into their own little houses. The same thing goes for a quotient, you know, quotient meaning division. They have the square root of a quotient. Again, it's the same thing as a quotient of their square roots. If we're going to look at an example, I don't know, let's say the square root of 1/10, right? That fraction of 1/10 is underneath the house together, but, you know, sometimes looking at that doesn't make our life easier. So, but what we can do is we can separate that fraction into 2 separate houses, right? So instead of looking at the square root of a fraction of being 1/10, now I'm looking at 2 separate pieces. I'm looking at the square root of 1 and I'm looking at the square root of 10, okay? And we're gonna maybe get into some examples here to where, you know, separating these guys out definitely makes life a lot easier for us here. All right, so let's look at some examples here. Letter B is the square root of 48. Again, 48 isn't a perfect square, but we need to find, does 48 have a perfect square involved? If we know a perfect square that goes into 48, we can separate out and go. The way I'm going to show you how to do this is, we've already talked about how to find the GCF and LCM of numbers. So the process of being able to break down numbers is already there. So what I'm going to do is I'm going to break down 48. And I know 48 is 4 times 12. Okay, so we're going to get this down into prime numbers. So 4 is the same thing as 2 times 2. 12 is 3 times 4, which 4 is 2 times 2. Okay, however you get down to the bottom of it, it doesn't matter. We'll probably have some different routes, but as long as we have a product of primes. Okay, so I'm going to list these out. I have 2 times 2 times 2 times 2 times 3. And, you know, when we're talking about the square root, how we talked about how it's perfect squares, so we need to find the perfect squares, right? We need to find what numbers multiply each other, you know, get us to our number, right? So I'm going to go ahead and draw our house. I know stuff's going to have to go inside the house and outside the house. So now that I have these numbers brought down as, you know, product of primes, I'm going to pull out the pairs here. And I've got a pair of 2's, right? 2 times 2 is 4. 4 is our perfect square. That's going to come out of the house. Okay, well, notice how we have another pair of 2's, right? That's a perfect square, right? We have the same number being multiplied each other. That is also going to come out of the house. And notice how, you know, I am multiplying here. Anytime we're really dealing with all this square root stuff, we're dealing with the operation of multiplication, okay? Now, that leaves me with this 3. Well, this 3 doesn't have a pair to match up with. He's kind of a loner, so what he's going to do is he's going to stay inside the house, okay? So whenever we have a matching pair, we have that perfect square that we can pull out. However many there are, you know, in this particular case, we had 2 2's we could pull out. We need to make sure we're pulling all of them out, okay? So now we're just going to simplify. 2 times 2 is 4, and we've got the square root of 3 out. Okay, so it is just getting into in simplest terms. You know, when we're talking about simplifying these square roots, it is not in simplest form when we have a number underneath the house that still has a perfect square involved. And in this particular case, we have a 3 underneath the square root. This is a prime number, so the only thing that goes into a 3 is 1 and 3. So yeah, that doesn't have a perfect square. Let's look at D. Okay, so very similar setup. Again, we need to break down 45. If you can see the biggest perfect square that goes into 45 right away, cool, go for it. If not, we need to break this down. Well, I know 45 is 9 times 5. Okay, and maybe you catch it right away that 9 is a perfect square. So what you can do, maybe the faster way here, is you know this is square root of 9 times the square root of 5. Well, square root of 9 is 3. Boom, done. Okay, but that's kind of the fast, quick way. If you can see the perfect square right away, go for it. If not, we need to break down these values. A 5 is prime, so we can't go any further. So if I write out its prime factorization, we have 3 times 3 times 5. And again, I'm searching for pairs, right? I want to know, you know, what numbers are being multiplied together to give me that perfect square. Well, we should notice that we've got a pair of 3's, right? So what I'm going to do is I'm going to take that pair and I'm going to pull him out of the house. And notice you have this loner 5. He doesn't have a 5. He doesn't have a match. That single guy is going to stay inside of the house. Okay, so again, inside the house at 5 does not have a perfect square involved. So this is in its simplest form. And just like the fast way told us, okay, if we can identify that perfect square, this guy simplifies out to be 3 radical 5. Cool. Okay, maybe let's look at some fractions here. So let's look over at example C. So we have the square root of 8/25. Maybe one thing that I would do is I would look to see if that fraction reduces. If you hit, you have to simplify here, right? So if you don't simplify now, and it can be simplified, you'll have to simplify in the end anyway. So if you can break these numbers down any further, I would maybe suggest doing so. 8/25. It doesn't go any further. Okay, so now this comes back to the quotient property that we discussed earlier. The square root of a quotient is quotient of their square root. So we don't have to look at this fraction in its entirety. What I can do is I can separate these guys out into their own separate houses. Cool, and what that's going to allow me to do is I know 25 is a perfect square, so I can go ahead and simplify that guy out. So I have the square root of 8. We can't do anything with that just yet, but I know what the square root of 25 is, right? 5 times 5 is 25, so I can go ahead and break that out. But when we're doing this quotient stuff, it does presume a problem with Now I've got 2 radicals I have to deal with, so we've got to look at this square root of 8. And all I'm going to do is I'm going to handle this just like we did the last 2 examples with B and D. I'm going to break down 8, which 8 says 2 times 2 times 2, 2 3 times. I have a pair of 2's, so it looks like this is 2 radical 2. Okay, so that guy is a 2 radical 2. Now on in the numerator on top of my fraction there, and I have this 5 that's kind of hanging out in the bottom. Look to simplify. So the radical, we can't simplify something that's outside of a radical with something that's on the inside of a radical, so we don't even look at that just right now. We have a coefficient of it and a 5 in the bottom, 2/5. That doesn't go any further. That can't be simplified. So I'm going to circle that and go. Okay, let's look at something similar to that guy as letter F. Again, we have a fraction. Again, if we don't simplify now, we will have to simplify in the end. So what I'm going to do is I'm going to look at this 12/100ths and see if I can break that down. And you should anticipate this can be broken down because they're both even. And it looks like 12/100 actually simplifies down to be 3/25. Okay, so just making our numbers a little bit smaller here, maybe more manageable. So what we say, 12/100 is 3/25. Okay, well, I don't know what the square root of 3/25 is. That's pretty difficult to, find the square root of a fraction. So what the quotient rule allowed us to do is instead of seeing 3/25, I can now see the square root of 3 over the square root of 25. Cool. Let's look to break down these radicals. I have a square root of 3 on top. Well, 3 is a prime number. That doesn't go any further, so I'm just going to leave that alone. On the bottom, I have a perfect square of 25. The square root of 25 is 5. And again, just kind of go back and check your bases here. Is there anything else that I can kind of reduce? By us reducing in the beginning, that kind of helps eliminate that idea. And then again, underneath the radical, I have a 3. That doesn't get broken down any further. So it looks like this guy simplifies out to be the square root of 3 over 5. All right, and one last example here. Let's look at the square root of 80. Again, if you can see the perfect square that goes in this, go ahead and pull it out, get on your way. If not, it's fine, whatever. Let's break it down. I know 80 is 8 times 10. 8 is 2 times 4, which is 2 times 2. 10 is 2 times 5. Again, it doesn't matter how you kind of break down this prime factorization tree. We should end up in the same spot at the end. Okay, so I'm gonna write these out. So I have a 2, a 2. I have 4 2's, and then a 5. Right, 1, 2, 3, 4. 4 2's and a 5. And again, I kind of do this to kind of help keep myself organized. I know stuff's going to have to go inside the house. Stuff has to go on the outside of the house. Now I've got my prime factorization. Let's start sorting this stuff out. I've got a pair of 2's. A pair of 2's going to come out. I have another pair of 2's. Then other pair of 2 is going to come out. And then at the end here, it looks like I've got this kind of loner 5. It doesn't have a perfect square to match with. We don't have another 5, so what he's going to do is just hang out in the house. And then in the end, kind of clean up what you've got going on here. We've got multiplication on the outside, so 2 times 2 is 4, square root of 5. Cool, so it looks like the square root of 80 is the same thing as saying 4 radical 5. And notice the 5 doesn't have a perfect square involved here, so we are in our simplest form. One way we can maybe double check this in your calculator. Okay, so remember you're simplifying. You're not altering the expression in any way, okay? It should be the same thing, it's just now in a more simpler form. So what I'm going to do is I'm going to put the square root of 80 in my calculator, and I get this decimal, 8.944, blah, 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 right? Well, if we're simplifying, I should have the same exact decimal, right? It should be the same number. It's just, again, in its more simpler form. So we just got an answer of 4 times a radical 5, right? And we should have that same exact decimal if we are just simplifying, and we do. So we know that we didn't alter this guy in any way. The only thing that we did is we wrote it in a more simpler manner, now that the square root does not have a perfect square involved. Okay, so this is what your practice will be on, just kind of breaking down these radicals. You're going to see some fractional stuff. You know, being able to break down these numbers, pull out your pairs, and simplify our radicals. Okay, so tomorrow we will look at, you know, what happens if variables kind of get involved here.